Good afternoon, colleagues. As introduced, I'm Shanice Makura, and I'm part of the Department of Computer Science at the University of Pretoria. And I'm part also of the Digital Forensic Science Research Group, which under Prof. Inventor, the first speaker of the day. So today I'm just going to talk to you about a research paper we've written. It's actually currently under review, and the title of the paper is Towards a Digital Forensic Readiness Model for 5G NFV Environments. So just to go to the next slide, which gives an outline of the presentation, I'll basically provide you an introduction. So for those who might not have understood the title, some of the terminologies like NFV, I'll provide that in the introduction section. Then mention the problem statement, then look at the research questions and the motivation behind this research. Then section 4, we'll look at the security challenges in 5G networks. Then specifically my contribution to the paper, which is the model itself, and the critical evaluation, then lastly, conclusion. So basically, hope to be done pretty soon. Okay. So many organizations are making use of cellular networks, and these cellular networks have existed for the past 30 years with the advent of the One Generation network, which was launched in Japan in 1979. And with further advancements, there's been other cellular technologies you are aware of, primarily the 2G in 1991, the 3G in 2001, 4G in 2008, and more recently the 5G, which was launched in 2019. And primarily we're making use of the 4G and 5G networks. I'm not sure, maybe can you show by raise of hands, all of you have got 5G smartphones? Okay, good. The rest I'm sure you have 4G, so you have an idea of what I'm trying to, or what my focus area is on. Okay, going to the next slide. So, due to the advent of these emerging technologies, AI, big data, machine learning, 4IR essentially, it has led to a growth in data creation. So all the wireless technologies are unable to handle these large amounts of data. And to process them at a faster speed is a challenge. That's why 5G was introduced. It's meant to bring these much needed advancements in wireless cellular network technologies by providing things like faster speed, high capacity, and low latency. You know, with 5G, you can have speeds up to 20 gigabits per second, whereas with current 4G LTE, you have something between the ranges of 20 to 250 megabytes per second. So through 5G networks have actually become more expanded and usable by mobile users and devices. And one key technology introduced in the 5G architecture is what they call the network function virtualization, or NFV, as well as network slicing. So by NFV, we actually mean we're replacing the network appliances, such as your routers, your switches, your load balancers, and we virtualize that those network components such that there is no need to actually have a physical device present. So that's basically what we mean when we say NFV. So I just included this slide for the benefit of those who might not understand what digital forensics is and what digital forensic readiness is. But essentially, that's the first definition. I'm not going to read all of it, of course, but the earliest known definition by the Digital Forensic Research Workshop, which happened in 2001. So basically, by forensics, I'm sure most of you understand, for any type of criminal investigation, there are certain forensics that operate. So let's say it's a murder investigation and a gun was used. There are those who analyze the type of weapon used, let's say the gun. They analyze the bullets used, and all those types of forensics. There are those who deal with trace evidence. There are those who deal with blood spatter analysis. You see, those are the various fields of forensics. So by digital forensics, we are mainly looking at if the crime was committed making use of an electronic device. Let's say a cell phone was used. Then we introduce cell phone forensics or mobile forensics. And then when you look at digital forensic readiness, it's actually a type of a proactive, it's actually sometimes called proactive forensics, where we actually do the forensics in real time, where we actually do not wait for the incident to happen. We do it before, during, and after, so it happens in real time. Okay. So just moving on to the problem statement, which this research paper is looking at. So due to the increase in the widespread use of 5G, it has created an avenue for cyber criminals to perform cyber attacks. And some of these cyber attacks include your DOS attacks, VNF location shift attacks. Some of these attacks, maybe you might not be familiar with them, like the VNF location shift, because it's specific to 5G, but it is a type of cyber attack. And some of them as well, DNS amplification, side channel, etc. So the primary challenge which is being faced by digital forensic investigators in investigating incidents that happen in this 5G infrastructure is that accessing the data in this 5G infrastructure is a big challenge. The current digital forensic tools made use of by the current digital forensic investigators, like there's some like FTK, NCASE, Forensic Explorer, you name them. They do not possess the possibility, the capability of extracting data from 5G infrastructure. So that prompts the need to utilize proactive forensics through the use of digital forensic readiness. Since also another challenge mentioned there is these 5G infrastructures could be sitting in different geographical places. So that gives a challenge to the digital investigator in collecting that evidence, because now it means he has to go to this infrastructure and go to another infrastructure which might be kilometers away, right? So the main problem which I was trying to address here is that there exists little, if any, way of applying digital forensic readiness processes within a 5G NFV environment. So what are the questions or research questions which you can drive or expand to make this problem statement make sense? So the first one is, what are the security and investigative challenges in a 5G NFV environment that prompt the need for implementing digital forensic readiness? So it's good to understand these challenges so as to have a motivation behind the need to have DFR in the first place, right? And then what standards are currently being used in digital forensic readiness that can be applied to 5G NFV environments? The second research question is mainly meant to ensure that the data we collect is admissible in a court of law. So for it to be admissible, it has to follow known forensic standards. Otherwise, the moment you try to present your evidence in a court of law, they will dismiss it. So the second research question was trying to see, okay, are there any standards that we can make use of to apply it to 5G NFV environments? And then lastly, to what extent is it possible to create a model that could assist digital forensic investigators when investigating incidents that occur within 5G environments. This research question forms part of my model, of which I'm just going to show you the high-level component of the model. Research motivation, or what motivated me to focus on this or 5G NFV environments. First one, the lack of processes and standards in applying digital forensic readiness in a 5G environment, being a new technology and also introducing these new features like NFV. There are no known standards or processes specifically tailored for 5G. Then another motivation, obviously, the increase in the cybersecurity threats, and specifically some of them I mentioned. I'm going to look at some of them, actually in the coming slide. These cybersecurity threats which are targeting 5G networks. Then also, as part of my contribution, aid the organization and law enforcement officials when investigating any incidents that happen within a 5G network. Okay, so what are some of those security challenges? Here, this is just 3 of them, of which this is not a security challenge, but it's just highlighting where a security challenge is encountered. Network slicing is another key technology within the 5G network. However, there are potential security concerns which include unauthorized access, because in a typical 5G network, it's just unfortunate I don't have a picture to show you. I would have loved to, just that because of time constraints, I had to make sure my slides are quite short. So there could be unauthorized access between the slices, or a resource contention where one slice is requiring more resources apart from the other. Then another challenge is monitoring network traffic and anomalies within the NFV itself. Then the last security challenge which I mentioned there is VM escape. So this one is mainly looking at when an attacker exploits some of the vulnerabilities that exist on a virtualized platform, like NFV, for instance. Apart from the security challenges, there's also investigation challenges. The investigators investigating those incidents that happen on 5G platforms, they face some of these challenges, and the chief one is the lack of standardization, where there's no proper standard or procedures or guidelines to follow that are specifically tailored for these type of environments. It being a new technology, yeah, there isn't any currently known standard. Then the diverse network components, I didn't mention most of them. I just mentioned a few of the components, and the existence of these network components make it difficult for digital forensic investigators to investigate incidences, because the current tools are not capable of extracting digital information from all of these tools. Okay, so having highlighted these challenges, I then proposed a digital forensic or a 5G NFV forensic readiness model. So the forensic model is actually meant to incorporate the current structure of the 5G network or 5G NFV network, and we introduce the model within that network such that, or platform rather, such that we are able to extract digital information in a secure way and store it in a forensic database. So I'm just going to highlight, I hope you can see my pointer here. Is it visible enough? Okay. So it has steps 1, 2, 3, up to 6. So the instance here where you see NFVI is actually stands for Network Function Virtualization Infrastructure, like the underlying infrastructure required for you to run the NFV platform. So inside the NFV platform, you could have one or more multiple instances of what we call the virtual network functions. So each of those appliances which I was mentioning, the routers, the firewalls, load balancers, you can simulate them using these VNFs. In this case, it's just showing you 3 VNFs. So in this stage, what I'm planning to do is to introduce a prototype which is actually able to extract digital information in each of these VNFs. And once the prototype collects that digital information, it goes, it's represented by number 2 here, where it says digital evidence collection. It's actually a collection of any potential digital evidence we might find, because it's very important to ensure that any digital evidence collected is secure. So that prompts the need for number 3, where you see digital evidence preservation. So in computer security, you know of the CAD triad. CAI, confidentiality, availability, and integrity. We need to always ensure those 3 are in place. So that's for integrity purposes, hashing is employed here. And then storage, on number 4, we store the digital information in a forensic database. And all these processes actually form of a proactive way. These are occurring even before an incident is detected within the 5G NFV platform. So this will be occurring in real time. And then for phases 5 and 6, those will occur post-incident, like let's say the incident has happened in DDoS, and then you call in the digital forensic investigator to come in to the investigation. The digital forensic investigator will just start there by analysis. The investigator won't need to do the collection, since this has already been done. So that, in effect, saves the time to perform the forensic investigation and also the reporting. Okay. Then in critical evaluation, so one feature of the model is that it does include some digital forensic readiness processes, and these are the benefits of leading to cost savings, as have been just mentioned in the previous slide, and also incident preparedness, where now the digital forensic investigator doesn't have to wonder, okay, where do I start? You know, the 5G network just being something new for the investigator. If there is a place where the investigator can start is on the collected evidence, or potential evidence rather, they can start from there. The prototype has the advantage that it will, okay, because it's still under development, it will be collecting this data regardless of geographical location, so it's not restricted to saying to where specific 5G infrastructure is. The hashing ensures integrity is maintained, and also the storage in a forensic database. Compliance to one of the known standards in digital investigations will ensure that the digital evidence we collect is admissible in a court of law, such that if the digital forensic investigator is to present that evidence in a court of law, there won't be any problem, because you just say it actually adheres, the process followed in collecting the evidence adheres to known standards, so there won't be any problem there. Okay, conclusion. So we see the 5G network usage is increasing even here in South Africa. MTN and Vodacom, yes, they are currently just focused on cities, but they are expanding their network, 5G network infrastructure to other areas as well. However, the use of those 5G network infrastructures has led to an increase in the cyber threats. So there's always need to develop these new techniques that address those incidences that occur within the 5G network. My thought is if this also could be applied even to 6G. I know it hasn't been, it's not yet in use, but when that time comes, we could also apply the same model to 6G as well. And that's about it. Thank you.
At University of Pretoria, I'm currently doing my master's under Prof. So my topic is secure storage architecture for hosting digital forensic data in the public cloud. So I'll just go through the outline of my presentation. Okay, so for this presentation, I will discuss the introduction, where I will give a bit of a background on my topic, and then I will also give a brief overview of the need of why we need a secure storage for digital evidence. I will also address the challenges within public cloud storage, as the solution will be implemented in public cloud storage. I will also talk about problem statement, the objectives of the research, and the requirements for cloud storage for both the cloud service provider and the cloud user. I will also talk about the standards, industry standards, and then compliance for cloud storage. And also I will give a bit of description on how to achieve secure storage. I will also give a high-level overview on my proposed solution as the current state of my research. I'm currently just busy. I just started on working on the high-level solution, so I don't have a diagram or anything, but it's something that I'm currently working on, so I'll also talk about that. So overall, my presentation for today, I'm going to be talking about the work from my proposal and also literature review, as I'm still working on the high-level solution. So secure storage architecture is basically a structure which is a structure. Okay, sorry. Sorry everyone, I got a bit distracted with the light. Oh, okay, sorry, thank you. So as I was still saying, so a secure storage architecture is basically just a structure or a well-designed framework which is used to ensure confidentiality and integrity, and also availability of the data which is stored in the cloud, and also protecting it from tampering or loss or any threats. So this is the type of architecture which is implemented to create a secure environment for storing sensitive information, such as personal information and valuable information, for example, digital forensic evidence. So why do we need digital secure storage architecture for digital forensics? So the need for the architecture arises from okay, sorry, I'll start again. So the need for a secure storage digital forensic architecture arises from a digital forensic process which involves collecting and storing evidence. So the evidence that is collected needs to be preserved in some sort of storage. So Okay, thank you. So the evidence that is collected during investigation process needs to be stored in some sort of storage. So normally they use like a digital forensic lab to store digital evidence, but you can also use public cloud storage as it costs less compared to like other cloud storage. So on this slide, I will just do a comparison of why public cloud storage is more useful to use for digital evidence over private cloud. One of the reasons is that it offers a pay-as-you-go model. So you pay for the service and the time that you use the service. But for a private cloud, you'll need to build the cloud, the storage, the environment from scratch. So you'll need hardware. You'll also need like individuals that are experienced to maintain your software. Also, like with public cloud, when it comes as far as digital forensic is concerned. So you are, as digital forensic, like normally work with like large amounts of data. So using public cloud, they're able to like add storage as they want because they can just like request and then get the service from the provider. But if they're using like private cloud, then they will have to like plan, and then it takes more time compared to when they're using public cloud. Also, public cloud enables like collaboration between digital forensic investigators. So different investigators sitting in different states can work on the same case without having a problem because they can access the environment using the internet. But with private cloud, it's only limited to the investigator within a certain lab. Also with public cloud, you can like get latest hardware and software upgrades from cloud service provider, as you're not the one who's like responsible for doing upgrade. You're just only using the service, but you're not responsible for the infrastructure. So private cloud, on the other hand, requires an ongoing investment. So also there are like advantages that I've mentioned with public cloud. There are also challenges within it when it comes to storing digital evidence. So the investigator doesn't have like a full control of the data that is stored in the public cloud. That means that the data can be vulnerable to threats, and then it might not be admissible in court. Also, the physical location of where the data is located can cause issues when it comes to administrable of data, as you'll need to follow the laws within the specific geographical location where the data is stored. Also, the security is sort of shared responsibility between the provider and the cloud user, meaning that the provider maintain the security within the infrastructure of the cloud, and then the cloud user, which in this case is the digital forensic investigator, they are responsible for the security inside the cloud. Yeah, those issues mentioned above are all related to data security. So the problem statement that this research aims to resolve is that digital forensic investigators have to store a large amount of forensical gathered data in some sort of cloud storage. In this case, we'll be experimenting with public cloud storage. But however, as the challenges that I've mentioned on the previous slides, like not having full control over the data, makes the evidence vulnerable to threats and other security issues. So with that all said, it is important that we explore this topic and design a secure storage architecture for forensic data. So the research questions that we hope to answer by the end of the research is to give a description of what a secure storage is, and then also talk about the techniques and process which are currently being used, and also address how cloud storage is continuously monitored for any threats to confidentiality and integrity of the data. Yeah, that's all. So the research objective is to design a secure storage architecture for digital forensic data in the public cloud environment, and also add continuous monitoring for that, so that if there's any issues, the investigator can get like alerts or notification before the situation gets out of hand and try to resolve it. And also to adhere to relevant compliance standards. So in this slide, I talk about cloud storage requirements. So this slide basically talks about what are the requirements for a cloud storage architecture to be considered to be secure. So that involves data security, and then also compliance and regulations to standards. And then the architecture should have monitoring implemented within the system, and also logging. And then it should also have backup and recovery, encryption, access control mechanisms, and then protection against virus. Designing this cloud storage architecture will also consider the Storage Network Industry Association data management standards, which involves a client-to-cloud standard, which basically talks about how the client interacts with the cloud, and then also the cloud data management standard, which talks about how data is managed in the cloud. It also involves encryption methods within the cloud. And then also we'll address cloud-to-cloud storage interaction standard, which talks about transferring data between cloud-to-cloud environment. So this slide here talks about the high-level solution that we're trying to work towards. So for high-level solution, for the problem statement, so the high-level solution revolves around integrating blockchain technology into public cloud architecture. So this solution will shift the current safeguard of digital forensic data in the public cloud, which will offer heightened levels of security and accountability. So some of the stuff that we looked into that makes blockchain technology more suitable for the problem statement is that blockchain is known to be immutability, which ensures that once data is stored in the cloud, it cannot be altered or tampered with. Another reason is that integrating blockchain is due to the distributed nodes, which makes the architecture significantly resistant to unauthorized modifications, and then also how blockchain is transparent and offers visibility for data transactions. Thank you, that's all.
My name is Tawo Chavalala. I am a vet student doing my honors this year. And also I'm an in-service trainee at CSR. So we are currently working on a project that's been ongoing for a couple of years at CSR. So basically it's a cyber threat exchange platform where different stakeholders, companies, and everyone who's involved within the whole network, cybersecurity network, is able to exchange threats and also share information, real-time information on whatever they've experienced, whether it's zero-day attacks and also previous attacks that have been there for years, which other entities are not aware of. So my topic is basically I'm working on the analytics of threats on Carry Honeypots, which is a system that's on the CTEP project. So that's what it's called. Basically, our project is the CTEP. It's a large project. So yeah. And what I'll be outlining is just what is a Carry Honeypot, the types of honeypot interactions, which we are kind of engaging with right now. Also basic setup of the Carry Honeypot and how does it work. Also we'll be outlining the predictions, the overview of the attacker behavior using machine learning, predicting ways in which you can predict whatever they're going to do, the attackers, using machine learning and the logs, which is kind of difficult so far because of the limitations that we have in LLP. And also, we will be also detecting, we'll be also discussing the anomaly detection on the honeypot logs and the limitations of NLP on the analytics of the logs. So what is a Carry Honeypot? Carry Honeypot is basically a medium and a high interaction SSH and a telnet protocol. So we use it to actually detect any sort of attacks that happen in real time, and also it can be used also to analyze the behavior of the attackers, right? So basically it's structured in such a way that you have a medium and a high interaction. So medium interactions are an emulated version, right, of the honeypot. So basically we're using an emulated SSH and Linux operating system, which is pretty much like a fake file system. So with that we can be able to track what the attackers' information in real time, and also we are able to monitor their behavior and what they actually do on whatever system that you place. So these systems are actually placed on a network and pretty much close to a real server. So they are important in helping us to understand what was the motive behind the attacks on our entity or on our business, and how then we can mitigate those risks and create a robust security measure for our organization. So the disadvantages of this is that attackers can easily detect if it's an emulation, and they can use commands such as ipconfig in Windows to actually detect if they're actually interacting with a fake or a medium interaction honeypot and not a real server. So they also provide a low attack information compared to high interaction honeypots, because we're not actually using a real operating system in the back end. You're actually using just a fake file system, which is not enough to extract whatever behaviors and whatever that they wanted to do with your system. Whereas high interaction honeypots, they provide a real service to the attacker, so the attacker won't be able to witness if they are being monitored by your business or whatever security researchers. So that's very important thing to do. But at the same time, it has its own limitations because you're actually compromising the systems, other systems which are nearby your server, so the attackers can actually use your system to attack those systems, so which is a bad thing. Yeah. So how is it structured? You just have an internet which is full of attackers, so they'll want to scan for the ports, the SSH 2 ports, and then they'll be able to then what we'll do with the honeypot, if it's a medium interaction honeypot, it will actually redirect them to the carry honeypot from your real server. So that then prevents your server from being attacked. And then we can actually study all the behaviors and interactions that are happening on your business or whatever. So there's types of threat analytics on the carry honeypot logs. So the first one is the statistical threat analytics approach, which is mostly used so far in research. So this is what's been done so far. So basically what we do is just we search for keywords in the carry honeypot, such as close connection, login fails, SSH version. And these keywords that we do search for, they provide information such as user passwords, connection durations, source IP, and the command input and connection protocols. So with the command input, it's very important in terms of behavior analytics, which we'll discuss later, and predicting the behavior of the attackers. So the types of analytics that we can derive from such an approach is the top 10 source IPs interacting with the carry honeypot, the top 10 usernames, and also many more, and also the geolocations of unique source IPs for login attempt events. And also some insights that you can also extract from such an approach. You'll be able to know that attackers or people who are trying to connect to your real server will try to do this at a very limited amount of time as possible, so that they can prevent being detected as soon as possible. So you'll be able to track which source IPs are that and from which location are they actually operating at. And also things like IP source, which log in during off working hours, where the security team or whoever is working in the space, they are not there. So you'll have a kind of like low interaction or low monitoring rate. And this is where we can be able to exploit the server during these times, because there's less monitoring happening, and which can be a threat to our or your organization, as it has some sort of valuable information. So these are, and also lastly, the addresses could be trying to perform some sort of dictionary attacks on the system, and which I think some of the business are not really structured to prevent against these attacks. Additional also methods or insights on this is that you can be able to flag addresses from different geolocations to trigger threat warnings. You can also be able to identify common attack patterns and approaches, which could allow attackers to achieve certain objectives with less interaction with the honeypot. So the one that I definitely would consider as an effective method of studying the attack behavior using carry honeypots is using machine learning to predict whatever certain approaches and behaviors of attackers in which they take root of. So firstly, we're gonna look at the attacker behavior modeling. So what we do is that in each log, we have a certain user which logs into the system, and he's gonna perform certain events which are sequential. So those events which are sequential, you can just model them as a session. And you can use that session to be able to track what the specific user has been trying to do with your system. And also, we can be able to extract certain features from these different sessions. And you'll be able to notice that with these different sessions, which are different users, you should be able to get unique features from each session, which allows you to make your model to be more adaptive to new threat behaviors and so on. So how we do the feature extraction is that we have common features in the carry honeypot log, which are timestamp, source IP, server location, and the session ID. We also have unique features, which are destination IP and destination port. So with the carry honeypot, you have different events, and all these events are kind of structured in a different way. So you have a kind of an unstructured data, which is kind of difficult to analyze or to perform machine learning on. So you have to perform data normalization so that you have some sort of a structured data so that you can perform an easier, ML pipeline. So the overview of how you would model this, or how we're planning to model this, is that we're going to do some sort of pre-processing using the THOE session format. So it's a cyber threat language for threat analytics. So it provides a data which is normalized, deduplication happens, and also you can be able to query data a bit more quicker compared to other CTLs. In the next stage, we'll be performing feature extraction, and you'll be extracting those common features and unique features so that we can perform data analytics on them, machine learning. So after that, we'll perform a k-fold cross-validation method so that we can be able to perform the testing and the training on the data set that we have extracted. And lastly, we'll be setting targets, right? So those targets are mainly the command type, the parameter, and the command, which is a compound command, and also the command success, if that command is successful or not. And we can be able to use that those parameters in order to detect the behavior of the attackers, various attackers, of course. And we'll be using LSTM, RNN, and FNN neural network, the feed-forward network, to perform a comparison between those networks. And as usual, we've seen that LSTM provides a high accuracy because it's able to capture a long dependencies of events, right? So with RNN, it's not able to do that because it doesn't have the sort of capability that LSTM has. And also LSTM has another family, which is a bidirectional LSTM, which is able to capture both in the forward and the backward direction, providing a high accuracy of your model, basically. Then we'll be going to anomaly detection based on ML on the carry honeypots. So this is just an overview. And basically we will just be capturing the data sets also from the carry honeypot, perform data normalization and deduplication. And we'll also be linking events into a single session, right, as I've explained. And we'll extract all those commands. Now we're just focusing on the commands which are, or on the events or features which are related to the commands, such as the source IP, the command sequence, and the session length. So with these features, we'll be able, or these targets, we'll be able to then detect some sort of unusual behavior in different attackers and how they actually conduct their attacks. So we can study new ways of attackers being able to conduct new methods of attacking your system, which is outside of the cybersecurity space. And also, we'll perform using unsupervised learning, since the data that we have literally has limited or no labels. So unsupervised learning provides a simpler way of doing this, and it's able to just be able to cluster your data in such a way that you can detect easily the anomalies within the logs. And also, I just go through some of the research papers that have been done so far on these analytics using machine learning on honeypot logs. And the first one, which is a GPT-2 parser. So basically what it does is that it uses these GPT-2 parser in order to take that unstructured honeypot log and structure it into a standardized data so that you can easily perform your machine learning for prediction, attacker behavior prediction. And the only limitation that it doesn't have is that it cannot do anomaly detection, so we can only do statistical analysis on it. Whereas with analysis of the attacker behavior, which is another paper, what they've done is that they are using the THOE format to standardize the data and normalize it, and also they can be able to do predict the attacker behavior with high accuracy, of course, and also be able to track or predict the next commands which can be attempted by the attacker. So this allows you to be kind of ahead of the attacker of what they're trying to do, and also to take some sort of mitigations on everything that they are planning to do on your system. So the use of NLP for threat analytics. So why is it important to use NLP on threat analytics? We are able to extract rich semantic information from the logs for accurate anomaly detection when we are using NLP. And also you are able to capture long dependencies on the logs and leading to precise attacker prediction. Also, major tasks which are performed on the Kari honeypot is text visualizations, NLP tasks. Text visualization, vectorization is important because you are able to extract the features without actually you manually deciding which features are important or not, and you are able to get as much information as possible from the logs to make more accurate decisions. And the classification models as well, such as LSTM, RNN, which are kind of like the best so far that we have, on deep learning, and some text pre-processing, which is more or less effortless compared to when you're using basic machine learning. Limitations and advantages using NLP on the logs. So with the log feature extraction, we have things like IDF and word-to-vector, which are some of the tools in NLP for feature extraction. So what does it do? As I mentioned before, it extracts rich data and rich context in the logs. Limitation that it has is that it expands the dimensionality of the data that will be going from your pre-processing to the training. So it's going to require more computational power, which is the only limitation that it has. Classification methods also, such as LSTM and GRU, they are good for capturing these long-term dependencies. And also, the limitations that they have is that they require a lot of data sets, right? So, which can be bad if you have few computational power for your machine learning. And if you are a startup as a business, it's gonna be less feasible to perform this. So with text pre-processing, as I said, the data is more unstructured. It's difficult to kind of perform and extract available features from this. So NLP allows us to be able to do this, to normalize the data and also to extract key features which can help us to predict the future attempts of the attackers. So the limitations with this is that you also have to train the data pre-processing, and also this leads to more computational power being used and accuracy concerns. So in conclusion, NLP can be used for log feature extraction as it extracts deep semantic log information compared to traditional feature extraction techniques. And also ML requires less data, which is an advantage compared to using NLP for both anomaly detection and attacker behavior. And also ML lacks the ability to just link relationships between the context of the log and allows you to be able to make some pretty good predictions, but at the same time it has limitations due to the lack of data pre-processing capabilities for extracting available features. So yeah, thanks very much.
Okay, good afternoon everyone. I'm Ajay Makan, and I'm well aware that I'm the last presentation of the day, but more so I'm standing between you and the cocktail evening that's waiting outside in the foyer. So I'm going to give you a quick overview of the South African National Research and Education Network, the South African NREN, or the SA NREN as we call it for short. And basically I'm just going to cover three aspects: the South African NREN and how SANREN fits into that, what's our infrastructure footprint, and what's our services. So before we get to the South African NREN, I wanted to take a step back and just look at what are NRENs in general. So they typically specialize network infrastructure and service providers. They exclusively support the country's research, education network, education communities, and innovation communities. So in the sense that we know as an ISP, that's for commodity and for public use, ISP service is a very small component of what NRENs provide. There are currently more than 130 NRENs globally, and to give you an idea, there's JISC in the UK, there's RNP in Brazil, ZAMREN in Zambia. Those of you that were at the keynote this morning would have heard Stein talking about ZAMREN. There's KeyNet in Kenya, Renew, Uganda, ARNet in Australia, just some examples. Most NRENs are not for profit. They're typically there to cover their costs, and the reason they structure that way is that they can give you as much services for as low cost as possible. Now in terms of the way the networks are designed, there's a major paradigm shift from the way corporate and your traditional telco communication providers are structured. So for an NREN, they're catering for a small number of large data flows instead of a large number of small data flows. So what does that mean? Basically, if you want as a researcher to be able to download terabytes of data, the network is structured for trying to move that kind of data instead of having hundreds and thousands of many users as in the normal public kind of networks that telcos provide for. They're specifically designed for NREN services, for science, research, education, and I'll get to some of the services that the South African NREN provides. They try and provide as much bandwidth as possible for as little cost as possible. And one of the ways they do that is by being cost recovery driven. And also you'll see most NRENs have very small teams to try and keep the costs low. They aim for very little to no contention ratio, and then they provision NREN services, and I'll get to that in later slides. So in that context, we have the South African NREN, and in South Africa we have two different organizations that fulfill the role of the NREN, and that's SANREN and TENET. Now, in terms of the functions, it's split. SANREN basically designs and deploys the network, and it develops advanced services specifically for the NREN community. TENET operates our network for us under a collaboration agreement with the CSIR. They host some of the production services. They represent South Africa at UbuntuNet Alliance, which is a regional research education network. And I'll explain how that works in subsequent slides. And then specifically, TENET has a subsidiary called SABIN, and SABIN is a vehicle that was specifically created to connect the TVET colleges to the South African NREN network. In terms of our network, we connect, it's a private network, it's closed, and there are eligibility criteria, and those are specific to science, research, education, and innovation entities. So those are publicly funded universities, science councils, science projects like the SKA, institutions that support innovation like the Technology Innovation Agency, NIPMO. There's academic hospitals, national libraries, and as I mentioned, the TVET colleges. So how does the SANREN side of things fit together? And basically SANREN, as you can see here, is one leg of 3 pillars in NICIS, with the Center for High Performance Computing. This is the National Conference, and the RISA. And in terms of its structure, we have these 3 legs. They together form NICIS, which is the National Integrated Cyber Infrastructure System. And the 3 legs are sort of encompassed by a Human Capital Development Program, HCD, and there are things like grant calls and e-research programs that encompass all of that. NICIS is a hosted program of the DSI, and it's hosted at the CSIR in the NGI cluster in the Smart Society division. Now coming to the network infrastructure, this is a network map, logical view of what our network looks like, and you can see this green links over here. That's our core dark fiber backbone. The other links are managed circuits, and then of course we've got a number of international access to international undersea cables capacity. And so if we go here, this is our dark fiber backbone. This is how it's physically routed in South Africa. It's 5 links. We putting the last one that goes from Blaney to Port Elizabeth in the new year. So, sorry. If you look at all these red circles here, those represent metropolitan area networks. And in South Africa, we have 9 of them deployed. We currently in the process of planning the one for Port Elizabeth. And on our website, if you have a look at this URL, you can actually go and have a look at what our metropolitan area networks look like and how they're interconnected. The sites are interconnected with one another. In terms of our international capacity, we've got access on 5 cables, 2 up to London, and then on WAX and SAT3 on the west coast, CCOM and EASY on the east coast, and then through a collaboration with various partners, we've got a direct route to the US. So how does all of this stack together, and what happens even though we've got the points where we end up with our capacity, Miami, London, and Amsterdam? From there, what happens? So basically, if you look at it, each country has an NREN, and together, depending on where you are geographically, the different NRENs belong to a regional REN. As I mentioned earlier, that TENET represents us at the regional REN, and ours is called UbuntuNet Alliance, and that's South and the East Coast of Africa. That's one regional REN. on the west coast, West and Central Africa, WAC REN, that's another regional REN, and then we've got the Arab states. And then we've got the physical infrastructure that connects the NRENs in the region together, and together they are connected up to in the UK, in London at Global Switch, and Netherlands at Amsterdam. And then from there we've got a number of other regional NRENs. Regional RENs that interconnect. So this is a very European-centric view. I couldn't find one that gives you a different view, but it illustrates the point that in Europe we've got points where we would then interconnect with other regional RENs. So in Europe there's Giant, represented in blue, and all these other colors represent other regional RENs. And so they all interconnect together and they peer their networks. And this is a way you at your university can connect with a researcher at the university across the globe, anywhere across the globe, because of the way the networks are designed and how NRENs, regional RENs, all collaborate with one another. I put in some stats of our NREN. So to give you an idea, this is the total traffic over 3 months for peering and transit. So basically what that graph is showing you is all the traffic that leaves or enters our network. And at its max in November, it was at 86.4 gigabits per second. To give an idea, when this graph was generated, it was currently at 8.11 gigabits per second. In terms of number of links, just an aggregate of all the links. And as I mentioned, there's different institutions that are building on our NREN, 732. We've got 879 devices deployed in the network. This is the type of devices in terms of the OEMs, and that view just gives it by which institution and what they've deployed. And we have a calculation that is done at the end of every financial year. So at 31st of March 2023, our total available capacity, so that's an aggregation of the capacity of all the links in the South African NREN, was sitting at 8,122.35 gigabits per second. So as I mentioned, universities that are all on our network, and science research and innovation entities, just some examples of who they are. To give you an idea of our infrastructure footprint, I put this up here so you can just see we've got this massive program of deploying infrastructure to build our network. We procure that from the South African telecommunications market. So some projects that we've completed, we've 10 gigabits per second managed bandwidth link for SALT. We just commissioned 100 gigabits link for Sareo in Carnarvon. And we've completed the participation in upgrade of capacity on WACS. So that'll give us more international capacity when we need it. Major projects that are in progress, we call them backbone extensions. So they go into all the regional areas, Eastern Cape, Limpopo, Mpumalanga, Free State, Northwest. So that tenders, we ran that, and they're busy in contracting for that. Here's just another list of more projects to mention. And we come to services. So from a South African NREN perspective, there's a range of services, and what I've done is I've just categorized it. So typically we give collaboration services, things like Zoom. We have content services, and that is mirrors of open source and free content, so you can get it in country. We have DNS services, network services, that's the connectivity, education, VPN, and we have open exchange points. Security services like the CSIRT that my colleague Renier spoke about earlier. We've got trust and identity services like EduRoam and Sapphire, and I'll touch on that a little bit later. And then we've got cloud and brokerage services like Figshare. So the whole point of how Sandrin does its services, we want to provision, or we try to develop and provision specialized services. They value added for research and education. So typically things you will not get from the market easily. If it is in the market, it might be expensive, so we try and do it from a brokerage perspective where we aggregate the demand and try and negotiate favorable pricing for our beneficiaries. We're constantly looking at trying to augment our service offerings to support our beneficiaries. So this is EduRoam that I just want to quickly touch on. I'm sure all of you know of EduRoam. You should have it at your institution. If you don't, please come and chat to me. Let's see what we can do to get it there. But typically it's a federated way to get Wi-Fi access at all participating institutions. If you've come through OR Tambo or Cape Town International, you would find EduRoam there, so you didn't have to worry. You've got Wi-Fi access as you step off the plane. You can go to the website, and that map is just showing in the Western Cape the places that you can find EduRoam. Then we have Sapphire. It's a federated identity service for our identity federation for our South African NREN. There are more than 60 of these across the globe, and the idea is to make it easy to share research and resources and to promote collaborations. So once you've got the federated access, it's easier to be able to enable the collaborations. When I did this check now in September, those were the service providers, African Regions Cloud, DERISA, the Education VPN for South Africa, Figshare, FileSender. Sandrin also provides data transfer service, and we do that via two tools. Or the one is FileSender. It's extensively used by researchers at universities, and that's typically to move files up to 100 gigabytes. Then we've got specialized architecture in the form of data transfer nodes, and there we want to transfer hundreds of gigabytes and even terabytes of data. We specifically use Globus, and we're in the process of deploying 100 gig nodes. We've got 3 deployed already in our network, and it's usable, but we're still in the testing and the commissioning phase. There's still some issues that we're trying to sort out. To give you an idea, with supercomputing now in November, we tried to do a test to supercomputing that was held in Denver, Colorado. And between our DTN, data transfer node here in South Africa, and the one in Colorado, memory tests show that we could transfer close to 90 gigabits per second memory to memory. And just in this week, we started to do disk tests. And the disk tests, if I recall, we were able to transfer at around between 40 to 50 gigabits per second. And we did a transfer of, I think, a 1 terabyte file in like 3 minutes. This was disk to disk from Johannesburg across the terrestrial network, undersea cable, across the terrestrial network in the US to a DTN in Colorado. And that's without a lot of tuning. So as we tune it, we'll probably increase that data transfer rate. And that is to allow you to get, in terms of if you have data sets that you want to get from US collaborators, so you can use it to get it over, so you don't have to ship disks as in any previous years. Then we also have a PERT team, and basically what they help with is when you have troubles in transferring your data, there's bottlenecks in your network, they're a specialized team that can help to do some diagnosis and troubleshoot to try and optimize the paths for you, so you can do that data transfer. We also have specific tools deployed in the form of Persona that helps with those diagnoses, a specific toolkit that allows you to our team to actually figure out where there may be problems in the network. We're also in the process of deploying Persona nodes at 100 gigabit capable, because as you know, our network is 100 gigabit capable. Then I'm not going to touch too much on the CSIRT. My colleague Renier has already done that. Except to maybe just add to what he spoke about in terms of the cybersecurity challenge that's happening at Krugergate Hotel. These are the teams that are finalists, and then they're competing in person at the Krugergate. And I just wanted to highlight who our sponsors are for this year's challenge. Without them, it makes it very difficult to host it for our students. And that's basically it, in a very...
AG, as a former colleague, what opportunity do I have at my institution with the EdRoom implementation? How does one go about it if we are interested? Thank you.
Sure. Okay, so that's an easy one. We can chat offline and I can give you the details of who to contact. It's basically putting in touch your IT department with the Tenet group that's actually managing the EduRoam service. It's very easy. It's just a little bit of setup on your side and off you can go.